situation was very similar to one I used in evolving hardware. Apparently, scientists, they do like to keep themselves to the toy problems, and they do not want to explore over realistic problems. Okay, so this is a list showing you examples of paperworks. So we were trying to find any networks which we were having, and looking on complexity level, which we calculated complexity levels of the networks. Okay, and what we found, so all papers which we found so far were merely getting to the complexity which was given to us. So it was something that we were not expected to do straight away. So because we said, okay, so we will be clever, we'll go through all journal papers, try to hit the most complex networks, try to see their solutions, and try to learn something. We did not expect that the gap will be quite big from when we start to apply for real problem and when we were just looking into this. Just for you to understand, we were our initial problem, which was addressing the following. So we had nearly 3,000 nodes. We had 135,000 ages. Okay, so we had a data of 24 months, monthly period. So basically, all these graphs which we have so far times 24, because we needed to get solutions for individual months coming up. So this is how departments work. We need to have individual solutions. Okay, and for each of these, we have 30 products. So in order to hit this, so basically we were trying to make sure that we have a mixture. We don't have only like tractors, only different type of products. We were looking at some components, which has been built in different sources. And we were looking for some assembly points, which we were introducing. And we were looking for some dealer locations to start with, and 48 shipping regions to start. So we were slightly reduced our problem, but the complexity still stays the same there. So this was our first hit. So this is something which we did not expect to happen. Considering the amount of work has been done, it has not been covered exactly what we were expecting. Just for you to understand a little bit more on complexity problem, I visualize one of our solutions on the problem. Okay, so we are looking on a global supply chain. So it means that all these white lines, can you really see it? Yeah. So this is the paths and solutions we have. Okay, so we have located in simplify a little bit of our locations. Can you really see? Just through simplifying course data, because when we start to speak about this size of network, considering that we haven't got any experience previously, what we want to do, we want to get a little bit of course introduction before we get to a bit more exact solution. So we basically introduce this hexagonal parts. We have introduced the course locations and anything, and this network looks like the way how we visualize. So it's a real example from what we have done. Now, when we start to work on this, we started with very simple. We basically, whenever you work in any type of research in anything, what you really do, you're trying to find out how your algorithm works and how the current system at the moment is working. So basically, how their current system working, what they are getting, could we get at least matchable results. Okay, and for this, we basically started with something which is basically baseline. Okay. Now, when we started to work, we were working in two teams. It was from one team from the university, from the people who are working here, and the second one, it was basically a team from the campus who was the trainers.
Okay, get a better view of you. Sorry about that.
And how about this? Ah, you have both, yeah? All right. Okay. Seems like a spine on you. I was more comfortable with another one. Have you ever heard about like sort of robots are taking over? Okay, the audience. I do feel like sort of robots like sort of they're having some priorities and they're taking over our audience.
I haven't said exterminating yet.
But yeah. So basically, we had like sort of a team, and it's like sort of inside the companies we had different departments that I explained. We had the different conflicting interests, and we needed to make sure that we manage somehow all of them. But before we can understand what we can do and what type of approaches we can do, we basically define the baseline. We define the baseline, what is currently the way how we perform the company supply chain to start with. Okay, we tried a couple of algorithms. We tried evolutionary strategy algorithm and we tried ant-colony algorithms. Okay, surprisingly, both of them came out very well. The only difference is we found that ant-colony algorithm was slightly faster than evolutionary strategy. As a result, with basically all other rounds which were done, we were concentrating on ant-colony algorithm. But speaking about this, if any of you, I'll explain you slightly a little bit more on ant-colony algorithm later on. But if you know the basics of ant-colonies, ant-colony algorithms has been developed in such ways that we can find the best paths from source to food, to get the food. So basically, these algorithms were concentrated on finding the graph, the most optimal graph problem. So basically, this algorithm was naturally fitting quite well into graph. And obviously, like sort of, we started with some simple algorithm, just looking on what is could be done and what we can get. And this is the structure, like sort of, when we start to look on from production sources to the ports, from other ports and to the dealers, you could really see the layers on. This is the structures of the networks which we were getting. Okay. So what we did next? So we've done the algorithm, so it was working, it was fine. The issues which we had start with, we were trying to implement, because the project was, when we started, I had students with very limited programming skills, so we needed to get some quick designs. We said we are going to have a quick fix. So the company produced our data in Excel file. We're not going to bother a lot. We are going to, what we're going to do, we're going to write VBA scripts and everything will work fine. Okay, we wrote VBA scripts. We get for HPC data to the company. It took them 1.5 months to run on HPC. Okay, so and one of the reasons what was happening is like sort of once we started to look into all the data, it's apparently when you run on Excel, Excel is when you write any VBA code on Excel, it doesn't like any type of parallelization. Okay, so we try to maximize, and if you have ever tried to write any programs on VBA, it will never use 100% of resources of your PC. Okay. In addition to this, even if you have multi-core computer, it will always use only one core. It would not allow you to go to several multi-core solutions. Okay. Well, we didn't know at the time, so we know now. Okay, so when we start to think about parallelization, if you want to get clever solutions, don't use VBA. So this is the lesson we learned. Well, it's, you see, like sort of when we speak about like sort of this type of problems, if you have the people who are very well skilled in programming and they can catch up very quickly with programming skills, you will never go for VBA. You will get something like C++ or Java, something that you will just build up very well. Okay, we are speaking about the quite very much heterogeneous environment where we have to work with skills of people they have. Either we need to build up extremely quickly to the level they want, or try to utilize maximum of the skills they have to deliver what they have delivered. Okay, for us in the first stage, what we needed to have something working. Okay, and this was solution. So we get algorithms, it was getting solutions. Nobody told us that it needs to be faster until we found out. And obviously, if we'll start to want these solutions, and it will take us 1.5 months to find, it's out of any realistic touch, simply because by the time we will get solutions, it will be far too old. So no matter how proud we were to get the solution, yeah, we get some other problems coming up. In addition to this, we started to look some variations. We started to add the energy cost. We started to optimize and start to look, what if the energy cost is going to be variable? Can our network be resilient to the energy prices? Okay. So we started to introduce not only one energy cost, which we'll be using through globally, we started to introduce variations, which we'll be looking and applying to this. So we started to build up a bit of complexity on algorithm. Okay, so and this is where we were changing our architectural bits and pieces, and I'll show you how our final solution is look like. Okay, it was a painful process, but we get there. Also, we started to look on land commitments, like sort of apparently, like sort of the companies which operate in ferry companies, they do like to keep their customers longer you're using lane. Yeah, so longer you're using their services is cheaper. If you're going to switch the services from one to another one, it's a bit longer. So it's become the game not only inside of 1 month, it's become a game how many months in a row you could use the same lane for your services. Okay, so we started to introduce this. At the end of the day, inventory it costs quite a lot, so we don't want to keep our inventory in anywhere. We want to make sure that if it says we deliver our products by 1st of April, we want to deliver these products. We don't want to keep anywhere to locations, because anytime we want to store somewhere, our heavy machines will have to pay for inventories. So we started to introduce some inventory costs. And on top of this tariff. So we started to build up the complexity bit by bit as it goes, but we did this once we changed our system and it was looking faster, not 1.5 months. Okay. So one thing is to make sure if you're thinking about prioritization, very quick fix on anything, never use VBA. So we learn in a way how it goes. Surprisingly, what we managed to have at the end, by going through all these changes, what we found out, based on their baseline, based on their solution, we did manage to achieve 4.6% of marginal profit. Sounds very simple. When I saw this number, I said, well, I think we can do better. Okay. But when you start to think that we are speaking about 4.6% on global supply chain network, the numbers suddenly going up significantly. Okay, but it took me some couple of days to realize we are speaking about the global network when you start to look on comparison, because I used to get like 20% off easily and everything and so on. So apparently their network was really very good optimized also, but we started, and we needed to do quite a lot of variations, making sure that all these dynamics which is coming in the real world, which will incorporated will give some marginal profit out of it. Okay, so this was our journey to get to the line where we can have reasonable solution within reasonable time. Okay. Now, this is what we saw, what we achieved when we start to look at variations, when we start to modify anything and so on. Now, you could really see, like summarizing our problem and what is the nature. First of all, it was a fairly complex problem. Okay. When we started to look at the data, when we started to collect the data were using different sources. Okay, to get the network and anything, but we're not getting network like sort of give us and so on inside of corporation, inside of their company. Different departments store data in different sources. So what is happening? So we needed to do very careful data handling as well to making sure that it works quite easily. Also, like sort of. Thanks to our first experience with VBA, what we found out that we need to get a solution within reasonable time. If we'll start to run our computers, and HPC was not helping in our particular case, okay, so it was run on HPC, but it was not helping. Even we tried to tweak prioritization and anything, it was not helping. So we understood that we needed to get an architectural bit and anything redesigned in such way that it will get in reasonable time. If you are not getting solution in reasonable time, it's become completely useless, no matter how good solution you could have. And this is where all these programming skills needed to come up. to make it work. And also what we found out is basically if we want to have our algorithm useful, and they can be later on used very well in the side of a company, it needs to be integrated. Okay, so it means we need to speak about some integratable things, such our interfacing and everything must be following not only standalone, but it must be interfacing with data handling captures, with visualizations, and anything to provide a full package. Otherwise, it's become useless. The way how we are running, like sort of all our algorithms, is like when we start to look into more. So at the university, we were far away from having HPC computer. So it means, for example, if we wanted to play a little bit with algorithms and find out the solutions, so we needed to ask all the time, like sort of literally every like sort of couple of days, if not every couple of half an hours, can you run for me this algorithm? Can you give me solutions back? Obviously, it was not working. Okay, so as a result, we needed to build a reasonable, fast solution which will work inside of our university team, so we can validate the algorithms, we can run them properly before we can run and scale up the solutions to the larger problems and see if it's going to be scalable. And this is where we were having some different platforms problems. Now, when we were, I mentioned several times already, when we run this project, we get in a little bit of heterogeneity in different levels of running this project. And this is where our restrictions were coming from, okay? First of all, it was from team perspective, what the skills we had in the team working, as well as looking on what available resources perspective we're having. So I'm just going to briefly explain to you. So team skills, university level. You could really see university level. We speak about undergraduate and postgraduate students. We have brilliant students. They have eager to learn. They have high motivations. You really don't need to do this. But the problem is they have a lot of motivation. They don't have experience. And it's not only they don't have experience, in their lives, maybe one of the most complex problem they ever wrote before they started to look at this project is my recipe book assignment in level 2, when we are trying to do some classes and interactions. So when they are coming to me, they're extremely proud of having this application and showing everyone, because this is what we achieve painfully working with me. During level 2, but they do a brilliant job. But when we speak about this type of level of problems, you really need to see some judgments and have a look. So when we start to speak about undergraduate students, they have a lot of motivation. You don't need to motivate. Very often they are quite quick learners, but because they are lacking experience, they don't have experience with teams. They never wrote fairly complex program as in your understanding, okay? For them, they wrote already very complex programs. When we start to engage a couple of classes, when we start to speak about some applications like this, it's slightly different. Okay, so normally undergraduate students, we are working here on final year projects. Final year project, it means we are speaking from September to March, part-time during the project. So basically, when you're trying to look at this, you cannot build up a lot of programming skills before we can do something else. So you need to try to utilize maximum what they have learned so far. And this is where the BA kit was coming up to start with. And you could understand now why I was jumping into VBA first, because we had all data presented in our spreadsheets to start with. Okay, and with very limited resources, we were looking. As time goes, we had some PG students, postgraduate students, master's level, and research PhD students. Okay, pleasure to work with them. Brilliant. Some of them had very good experience, like can lead. They learn very quick and anything and so on. They become a little bit like supervisors for our undergraduate students. We take care of them, and we started to open up and use new techniques. So we needed to make sure that in our team, inside of university, both students, undergraduate and postgraduate students, they work together. In addition to this, because undergraduate students, they have very short projects, like 6 months only, we needed to make sure we have sort of in transfer in between. At the same time, we will never get results which I was showing you if we were not working very close with company. And it means we needed to have a weekly meetings, we needed to discuss the results. As you could imagine, quite a bit of you may be working in the companies, you are doing programming on everyday basis. You are a very experienced one and you will be getting like sort of bored if you will be discussing inheritance during our meetings. Okay, so that's why, for example, we needed to get a balance. We needed to make sure that our team of students, all of them who were proud, who were doing brilliant work, they needed to catch up as fast as possible with company team. And some of them, they needed to utilize their skills quite well. This is one of our restrictions was. So it's like sort of, this project will be less painful and very quick completed if we had someone who experience working quite for a while in programming, start with and going on. So that's why, for example, maybe 5 years for you is quite long term. For us, working with students in anything is about the time when we just basically proudly say we did something. From another point of view, we had some limitations of resources, okay? So working with the companies, you need to understand like sort of what is requirements of a company and what way resources available for us from them. As well, we need to understand what resources we have. When we start to look at the resources, our university undergraduate students, very often when they work on undergraduate projects, final year projects, they would have either Windows-based PCs or Macs. So nowadays they will have a couple of multi-core computers, but it's about it. So if, for example, like they needed to get results, what we were doing, we were closing labs for a couple of days and we were running experiments all over labs on ordinary PCs we have in our labs just to get some results and have a look. When we start to speak about postgraduate students have access exactly the same as undergraduate students, but we started to have access to Linux servers, we started to have Linux accounts, we could schedule the jobs, we can run it. So it was a bit easier, so we didn't need to close our labs for several hours or several days at some point, so to get some results. And company, obviously we had everything that we have, but we also had some useful resources for HPC. But when we start to have interactions, we had access to HPC to run all results which we wanted, but we needed to make sure that at least our algorithms were working perfectly right before we can run on HPC. Okay, so otherwise we'll be just basically running all our program code in HPC and it will be easier. So if you could really see from what variations we have and from experiences we are speaking about at least Windows-based, Linux-based usage of platforms. We are speaking about HPC, single core or multi-core computers. So and when we speak about the program, we needed to develop a program the program code which will be running without modifications in one. If some of you are working with algorithms, you know if you change one small thing on algorithm, yeah, you need to make sure it will run exactly the same algorithm on different settings. So that's why we needed to make sure that our one single program code will run write our program, for example, for Windows-based. When we give to HPC, we needed to write the program code. We'll never get any good results. Okay, now, so this is our problems, our restrictions, and where we are coming out. So what was happening, understanding from our systems architectures, we had two major things which we needed to handle. So making sure that we could overcome all our restrictions and easily integratable, we need to make sure we have proper developed data handling. So data collected in the companies, exchange the data, visualization of the data, and also we need to make sure that when we run our programs and we have the data, it should be the fastest way to process the data as well. So what we found out when we were working with Excel file spreadsheets, so when you start, every single time you try to read and write something from spreadsheets, it takes ages. Okay, so now when we speak about how fast it could be, so it means we are speaking about the time reduced. And another part, so first we need to sort out the data handling, and another part is our optimizer. Again, optimizer must be run on different platforms, multi-platform. It needs to be a proper parallelization, but also the algorithm structure should not be changed from one to another one. Now, let's have a look from data handling. When we are looking on the data which was available and what we can do and bits which we were looking, options we had data was originally given to spreadsheets. Some data was presented in text databases and XML. So we ran a little bit of small tests. What we found out, the quickest way before you do anything, you get the data format, whatever it is, and you start to work with XML. For us, this was the fastest way to process any data accessible and anything. Simply because what is happening, like because you have several departments and all softwares are presented in different departments, it was easier and faster to write, to work for us internally with XML data, and now to then transfer all this data to any other formats required internally. And this is what we choose to do. So all our data inside of a program code was presented with XML format, and all others with spreadsheets. Now, from Optimizer's point of view, we are looking on all possibilities, and when we had a look at our requirements, we had single core computers, multi-core computers, Linux servers, HPCs, and we needed to get something which will run in reasonable time. So we needed to look on using different hardwares, and in addition, we need to look on Linux and Windows, but everything will be running in reasonable time as well. From Optimizer point of view, when we start to speak about optimization, algorithm. Okay. So for optimizers, we were trying several algorithms, and it could be integrated like sort of ant colony algorithm, genetic programming, linear programming. So basically, what we are speaking, like if we speak about data handling as a separate like sort of tool, which will allows us to combine different heterogeneous type of data in one and transfer in one format we can work with. Okay, so we will apply and plug in different type of optimizers quite easily and work. So once we sorted out the approach with data, it was easier to plug and play and use this data in different type of algorithms. So it makes our life a bit easier, definitely mine. Now, I mentioned to you that we were working a little bit on ant colonies. And the final solutions we've done several algorithms with ant colonies. Just for some of you, just for fun, if you don't know what is on, because I don't know the audience level. So we are speaking about the customers, for example, and we speak about our factories. And we have a population of ants, which are basically traveling from port N1 to port A3 and after them to one from manufacturing. Okay, and we are getting the ants, and once we are going from customers to different production sources. And once we found the solutions for ants, customers is the sources and production source is the food. And once we found the shortest path, and this shortest path could be the length, duration, okay, the cost of the lane, depending on what we are optimizing, okay. We are finding the most suitable lanes or residents. So this is how our ant colony algorithm was looking. This was our final solution, which we started to optimize and adopt. Okay. Now, if you will start to have a look on, remember our data handling and optimizers programs, what is happening with our algorithms, which could be written like sort of VBA, C++, we were getting through program compilation environments, and we were getting through our algorithm. Let's have a look a little bit more in details, something you may like a bit more. I was introducing you quite a bit. So this is quite very simplified way how we did it, but it's basically, this is happening. Our spreadsheet data files, which was presenting our data, okay? We would be with data sheets files will be converted to XML, okay? And this will be exporting data file. And after that, we will send it to XML parser in our optimizers and read and write data inside of optimizer. Once we finish, we'll be writing data in the import XML data file, which will be converted later on to the data file. So basically, we are speaking about, we have two distinct parts. Okay, one part is about data handling. So we are taking the original format of data only in the spreadsheet, and we are wrapping up using XML files. Okay, and we had optimizer. Now, if you start to have a look, this our approach was like sort of very simple approach for data handling, and at the same time here having XML parser written down, yeah? What has happened, like sort of now reading and writing data has become easier, and we can now plug in any optimizers algorithm we want to have it and work. And this is what I was saying, that it was makes our life easier in terms of integration of different type of algorithms, like ant colony algorithm or genetic algorithms and linear programming and so on. Now, looking at this, what we found in our main programming language, for which we are choosing, it was C++ standard 11, which was approved by ISO in 12 August 2012. So we found that basically this was most useful for us and works. Also, we were looking on Microsoft Visual C++ for Visual Studio Professional 2013. And we were using Linux G++ compiler version, GCC. We needed to make sure that all our programs were operating more or less on these platforms because of the available computers and everything. So basically, no matter how we were writing this program code, our program code must be portable among these three. And ant colonies is very much parallelized algorithm. It means we needed to use OpenMP. In our case, at the moment we are using version 3.1 for multi-core programming. We wanted to utilize maximum of resources is provided to us. And for exchanging for data, we were using XML for data structures definitions and TinyXML as parsing library. So this is our approach, how we handle all our restrictions of what type of programming languages we were looking for. Let's just have a look on C++ 11, a little bit for multi-platform implementation. Okay, so what is good for us in terms of context of the project which we were running this, okay, it's a lot of official standards functionalities were supported for all major platforms, and literally all platforms which we were using in this particular project were supported here. So, and that's why we needed to start to utilize one standard, which will be quite good. And also, what was very good, like sort of macros were platform dependent. So, for example, we can use Win32 or Win64 available on MS systems, or we can use GNUC available for Linux systems. So we started to see that we can write the program code which will be adaptable to the requirements and sources which we have. Remember that what we wanted, we didn't want to have like several versions of the programs written for different platforms, for different users and so on. We needed to have something that would be very well solidly used. Also, we were looking on libraries for file system interactions. We were using DirectH for on MS systems and SysTabsH and SysStatH for systems. Obviously, when you start to use libraries, you are very much binded to one another one. That's why we needed to make sure that the libraries we are used, it's the most either replaceable or similar libraries. getting on. Otherwise, the results which we are getting on one computer would not be transferable to another one. And what was very good for us, GNU make may be used for compilation in all major platforms. So basically, once we create GNU make, we'll be able to use different files. Okay. So here is an example of snippet of our program code, which is coming out. Okay, so here we are speaking about GNU make example. We were, for example, here we were looking on configurations for our high performance configuration, which we were using in actual program code. And for example, some static compilation library, which was something like this. So if you're looking for program code, it was maybe slightly more complex. We ended up with slightly more complex program code as needed, for example, to run either on HPC or on single computer. But because of requirements and our restrictions on resources, this was the only way we can have quite resistant algorithm and solid performance. Okay. Also, we were using OpenMP for multi-core parallel programming. Okay, so because of parallelization, it was easy to go. So we're using quite simple parallel directive. It's pragma in parallel form on the course. And we were doing some scheduling on parallel loop scheduling. Thanks. Okay, and we were using, for example, like used the data score attributes which we were defining by this. Now, when we started to run and introduce parallelization, obviously the time has been significantly reduced because we were trying to utilize all cores and everything. And when we speak about 100 iterations on 8 cores, process age was reduced, runtime requirements and improved search as visited portion of solution space is increased. So more visibility we have for solutions, better solution we are catching. Also, as I mentioned, we were working as a standard with XML as our format of data. So we were encoding our input files and output files using XML. We were using tiny XML. It's like efficiency plus static library, which used for XML documents parsing, so which we were using. Example was fairly easy for document parsing here on document navigation through the way how we did. Okay, and these ones, for example, formats of matrix and table representations, which we're using, so basically for researching and everything. I'm saying that basically this is what we found was the best for us, for our problem. Now, just for us to understand what this journey was coming from and what we started and what we were achieving, when we were running our performance on VBA, so on a single multi-core, we just even haven't attempted, because we tried to run, we closed our labs for a couple of weeks, and after a couple of weeks, we were not getting anywhere. So tried to run a computer for a couple of months, and after we had power cut, and having power cut, we never know what results will be. Okay, so but we know that, for example, for VBA, for the problems which we were considering, it was 1.5 months to start with. And when we start to look on our solutions, when we look on Windows, for single core, it was 500 seconds to find a solution when we optimize. Linux, for single core, it was 800 seconds. And for Windows, for 8 cores, it was 60 seconds. And Linux, for 16 cores, was 50 seconds. These results, you could really see, we started to get to the level when we can start to play algorithm and tidy up, because it was reasonable runtime, and we can improve. And this is one of the reasons we managed to improve algorithmic bits. Okay, and when we start to look on the same problem on HPC, it was only for 1.5 seconds. So it's basically, it was a big jump. So by the time you click, you're just basically getting results. Okay, in conclusion, so what in our solution, in our journey, which was going through, we found that OpenMP was extremely useful for multiple parallel programming to make sure that our program code would be steady run. We were using C++ 11 for multi-platform implementation, and standard data exchange format XML was very useful in terms of handling data and processing data inside Optimizer. I tried to make sure that I was more concentrated on programming, making your interest. I'm not sure how much I managed to cover this, but if you have any questions, happy to answer and show some more information. Thank you.
Yeah, right. Any questions?
Yes, when you're talking about using different kinds of C++ and having your program usable on all of them, presumably, I mean, obviously that means that you use a subset of each, and the subset that's common to each.
What we are trying to do, we're trying to eliminate any libraries.
Any difference, yes.
Yeah.
Now, there might be, it occurs to me that there might be some situations where there isn't anything in common, like in input-output in routines. Mm. So would you instruct your programmer to say, if you have a flag saying which platform it is, and then the instructions, if platform is such and such and such, and platform is such and such. Did you have to do that?
Yes, we did. So what was happening in reality, because in our case, in order to deliver results, it was important the algorithm structure was steady up and running. Okay. So it means that any algorithm must be written in such way that we would be using only the common libraries between different versions, and we would not use any specialized libraries in one language. We did it at the beginning, but after then we start to cut and rewrite the program code, making sure that we use only commonalities. Okay. Also, like sort of, the optimizer works in such way that once it's up and running, you could just basically up and running the same common things. But when you start to speak about input and outputs, this is only happening at the beginning of the optimizer, before we start loading the data, and at the end, when we finish. So basically, we know that algorithmic bits would not be touched. So basically, we were trying to eliminate any differences in libraries, and whenever we spot the differences, and we did, so we had some headaches, we needed to write these program codes, making sure that it's common. And in order to maximize the run and speed, because the speed I'm showing you here, it's basically, we are speaking about the reason why we managed to achieve these speeds is because we are reading and writing files only the limited time. So basically, when we start to display the solution, it does take some time for displaying and everything, and then we can start to use and separate for each type of platforms. But for example, you know very well, we tried to find the common visualization bits. At the moment, we failed. We found that it was like visualization between HPC and Linux works quite well. So because we are running very much on similar platforms, but with Windows, when we start to speak about the Windows, showing the Windows and anything for people who are using it, so you really need to write this stuff.
Which version of Windows were you using?
It's the latest one.
It's 8.1.
But well, we started with 8, but we started with earliest version. As its time goes, it was upgraded several times, and the process was, to be honest, was quite painful because we started like at layers. So basically, we never seen anything like this to achieve, and we never thought that this would be for us as a challenging from programming point of view. But when you start to see that you start to get reasonable results, you want to push forward. But because we were making sure that it works on all this, now all this will be integrated into the decision-making process of the company. But it's only because we managed to run on different platforms up and running, and algorithm by itself is stable in different environments when it's running.
Just a quick question or comment. I mean, regarding the visualization on different platforms, would it be a possibility to use Java? Because I mean, if you just were to write the visualizer, I mean, much as I understand, you have an output in.
Yeah, we are using Java. Yeah, this is like sort of.
Yeah. So, I mean, in XML, and then I mean, you could read that XML and present it, and well, it should kind of look the same on regardless of what the platform is. Yeah, maybe on Android.
Yes, because we choose the XML and we landed up with XML, it's basically unlock a lot of our opportunities rather than lock down. Okay, because we were using spreadsheets. After then, we started to use text files. We were using the databases. We were measuring the child rate and anything and so on. But the problem is what we found that sometimes the company would send you one spreadsheet. After then, they will change some rows and columns and everything. Okay, so and the text file will not be valid anymore. But XML was helping us sort out this out quite quickly.
Yeah, I was going back to the case study was Caterpillar, yeah? You said it's a 4.6 marginal increase. That translated into how many pounds?
It's millions of pounds.
Millions of pounds that they managed to save in a year or year?
Per month.
Per month? That's quite good. Yeah, it's a real life application.
It's like, so to be honest, like sort of, because I'm working on optimization, normally we are looking quite fairly modest numbers. When we come back, we were very excited, jumping around, and we said like 4.6%. Yes. You look at this and say, well, I think we can do better. Okay, and the process of realization comes only when you start to look on the scale. Because from my previous experience, I was always working with something called toy problems. I was truly 100% scientist. Okay, so like sort of dedicated to toy problems and anything else. So basically, I never thought like sort of if you will start to think about the team of undergraduate and postgraduate students managed to achieve something like this. I think these guys who were working on this project, they did a brilliant job. Because all this has been achieved with our undergraduate and postgraduate students. It was not like professional programmers which has been working on all this. But it's like sort of, it's millions. It's the same like yourself, 4.6 is not a lot.
Yeah.
When we are coming. But what is important, I think, for us, what was not challenging more is to find the approach to make sure that all this team of students with different skills and backgrounds in terms of programming, and being you as a programmer, you regard one lines of program like coming naturally, okay? So for the guys which they are proud of writing one class, declaration of a class, and they think they've done with programming, I can really see quite a bit of smiles now on yours. These are the guys who managed to get to these levels and so on. But I think like sort of we had Marco. Marco is my brilliant PhD student who is working here, and unfortunately he wasn't able to come here. He has done quite a lot of research and work on this to make sure that to speed up, because otherwise we won't be able to optimize and improve this.
Okay, so further questions?
You talked about you were searching for things that had already been published in this area. Yeah. I mean, presumably you are publishing?
Yes. We started to publish. We have filed a number of patents up to date. It has been filed 4 patents in this area. But also we start to publish. You could find information. For example, we publish papers on multi-objectivity. So again, we found some results which we haven't expected to find. For example, the people, if you are using multi-objective optimization, the people normally will use a simple weighting function to use. Apparently it's not that optimal. And when we start to look on the reasons why, it more comes to the soft solution that when you start to look in the market and algorithms available, most people, when they try to attempt this problem, they are not writing all program code from scratch 100%. So they use the libraries developed by someone else. So, and in this case, we're weighting libraries with weights like sort of the cost function will contribute to 40% for me. Like, I don't know, 40% will be resilience, 20% will be turnover. Okay, so it's basically it's easier for them to set up and run rather than to write any of any different type of more like sort of exponential projection of the fitnesses. But when we start to combine them together, it was clearly we were one of the worst performers. But it's like, I think we got a little bit of advantage over others because all our algorithm bits, we didn't use any libraries. So because we built up on all this, we had a lot of restrictions. And because we had a lot of restrictions, none of the existing libraries of algorithms would just not fit in by any means. I'm happy to send you the link, so where it's published. But there more papers. We had like encyclopedia paper which published an overview of existing work which we found out what was happening and a bit of overview of what has been done. Some more papers. So we happy to distribute and see.
Yeah, one of my thoughts when you talked about the lack of publication of this sort of thing when you went and looked was that there's so much potential value in this sort of thing that I wonder how much work has gone on in the past in lots of different areas, but has been kept quiet. Because it's got so much value.
Correct.
It's sort of refreshing to see you coming forward with something that to publish on it.
To be honest, if you have a look at this, in reality, like sort of